The length of the curve with this equation, where do we even begin with this? Well, let's combine the logs and see what happens. Can we remove all the logs? Well, the first thing we can do is bring that 2 up, and we can add these two together. Log a plus log b is log ab. So write it as log to base 10. I'm just going to write log here, but I mean base 10 throughout. 2 minus 2x multiplied by y plus 5. And now that I've got log of something equals log of something, I can just remove it. So x minus y squared is equal to 2 minus 2x y plus 5. Now, strictly speaking, these two things are not exactly identical because the first equation had some certain restrictions. And I want to talk about them now before I move on. So I always require that, because we're dealing with real numbers here, I need the argument for my log to be positive. So I need x minus y to be greater than 0, and therefore I must have that x is greater than y. That has to be the case, which is not necessarily true for this equation here. So it's like an extra condition that I'm including. I also need that 2 minus 2x is greater than 0, and that means x has to be less than 1. I'll just write that one down as well. And then y plus 5 has to be greater than 0, so y has to be greater than minus 5. Okay, so I mean that like from now on in all of the rest of this question, we have to have that is true. So let's see if we can think about this curve in more detail. I'm going to do that by expanding it out. So x squared, then minus 2xy plus y squared is equal to 2y plus 10 minus 2xy minus 10x. Those xy's looked a bit worrying at first, but now they're gone, and this is looking a lot like a circle. So x squared plus 10x plus y squared minus 2y equals 10. X plus 5 squared minus 25 plus y minus 1 squared minus 1 equals 10. X plus 5 squared plus y minus 1 squared is equal to 36, or 6 squared. And actually, that equation at the start has turned into the equation of a circle with center minus 5, 1, radius 6. Just with these, just want to reinforce that again. These conditions in red, they're also valid, or they're also necessary. So we've got minus 5, 1, put that here. And then I'm going to draw a circle. Okay, that would give me a radius of 5, so I'm just going to go a little bit beyond to say here. Let's put, these values as the furthest right. So I'm adding 6 to the x value. That would give me 1, 1. And actually, what that tells me is that x is always greater than 1. That's not a problem for this equation. If I go to the bottom, then it would be minus 5, minus 5. And actually, except I wouldn't include that value. So in fact, I should put a little, I just realized that would give me 0 inside the log. So I'll put a little circle there. I don't want to include it, or that one there. At the very top, I'd get minus 5, 7, which is all good. And over here, I'd have minus 11, 1. Now I just need to think about this x greater than y. So what I could do is draw the line y equals x. It's going to go through that 1, 1, and it's going to go through the minus 5, minus 5. And I'm interested in the points where, well, I prefer to write it as y less than x, which means we have to have the points that are below the line. And we've already ruled out the points like here themselves. I did an open circle. So what I actually have to do is this is not none of these points are valid. So I'm in fact going to get rid of them. And that original log equation is equivalent to this part of the circle. That is it. So what I can see is that actually I have a quarter circle, that very bottom bit. So the circumference is 2 pi r, so 2 pi times 6. But I have a quarter of that. If I want to find the length of the curve, it's just this bit here. I just need to divide it by 4, which gives me 12 pi over 3, and our answer is 3 pi. That is such a good question. Hope you enjoyed it. Well done.